Welcome to Syeadh Academy. Threads in operating system. In an operating system, threads are the smallest unit of execution within a process. They are lightweight and represent independent paths of execution that can run concurrently within the same process, sharing the same resources and memory space. Threads allow multiple tasks to be performed simultaneously, making use of modern multi-core processors efficiently. Threads in an operating system can be categorized into two main types. 1. User-level threads. 2. Kernel-level threads. User-level threads. User-level threads are managed entirely by the application or the user-level thread library without direct kernel support. The operating system is unaware of the existence of user-level threads, and all thread management is handled at the user level. Thread creation, scheduling, and switching are handled by user-level code, not involving the kernel. Since the kernel is not aware of user-level threads, if one thread in the process blocks, all threads in the process are blocked. User-level threads are more lightweight compared to kernel-level threads, as they have lower overhead for creation and management. However, they lack true parallelism on multi-core systems. Code, not involving the kernel. Advantages of user-level threads. The user threads can be easily implemented than the kernel thread. User-level threads can be applied to such types of operating systems that do not support threads at the kernel level. It is faster and efficient. Context switch time is shorter than the kernel-level threads. It does not require modifications of the operating system. Disadvantages of user-level threads. User-level threads lack coordination between the thread and the kernel. If a thread causes a page fault, the entire process is blocked. Kernel-level threads. Kernel-level threads are managed and supported directly by the operating system's kernel. Each thread is a separate entity as far as the kernel is concerned, which allows the kernel to schedule and manage threads independently, providing true parallelism on multi-core systems. Kernel-level threads can take advantage of multi-core processors, as each thread can be executed on a separate core simultaneously. Since kernel-level threads are directly managed by the kernel, a blocking system call in one thread does not affect other threads in the same process. However, creating and managing kernel-level threads typically requires more overhead than user-level threads due to interactions with the kernel. Advantages of kernel-level threads. The kernel-level thread is fully aware of all threads. The scheduler may decide to spend more CPU time in the process of threads being large numerical. The kernel-level thread is good for those applications that block the frequency. Disadvantages of kernel-level threads. The kernel thread manages and schedules all threads. The implementation of kernel threads is difficult than the user thread. The kernel-level thread is slower than user-level threads.